This presentation will be focused on egress simulations in buildings, where we'll be presenting innovative ideas on how to save lives. Even though we'll be presenting statistics regarding fires, this can easily be extrapolated to any kind of emergencies where people are going to have a very short time to save their own lives. When it comes to fires, the statistics are alarming. More than 3,000 people die in fires each year, and almost 20,000 are injured. FEMA creates reports on civilian fire fatalities in residential buildings, where they find that the most notable factors contributing to fatalities are fire patterns, egress, and escape problems. The egress problems include limited exits, and escape factors include excessive travel distances to the nearest clear exit. Everything while escaping. Fatalities occur while people are escaping. So with a well thought out plan and multiple escape options, chances for survival greatly increase. How is it done? Currently, World War design is based solely on standards and tables. Reality is never ever accounted for. Pretty much you divide the square footage of the room by the square footage required per person, and it tells you the widths of what? Of stairs, of doors, and the hallways. That's it. So if you follow these tables, not reality, just these tables, you're more likely to survive under emergency conditions. So where's the reality using this approach? Don't even look for it. There is none. Each project must be turned with evacuation routes, and they are. But these routes are only based solely on occupational factors to compute these widths. But this approach never analyzes reality. Life is never analyzed. Architectural layout where walls, furniture become obstacles. Stresses under any eventuality. Human speed, speed factors, spacing factors, interaction between people, critical escape distances, the different types of people, the gender, if they're handicapped, the alternatives, the safety, real evacuation times, based on everything that we've talked about, chaotic distributions, crowded areas, waiting queues. Why do we use simulations? Well, we use it for a number of reasons, but the most important is to provide numeric results. Time, because time saves lives. Simulation is the only real solution. Why? Because you simulate the behavior of people. You simulate the existing conditions and alternatives to save lives under adverse conditions. Okay? You estimate the benefit and the level of service, security, and mostly because you save lives. What is mobility analysis? It's the study of people interacting on complex networks, minimizing congestion problems under critical situations. So for any mobility project, you have different designs. Each design has its own benefits, so we compute the benefits that along with the cost, it's going to give you the best option. And we model using microscopic methodology. Okay, it's not constant, it's microscopic, and it's based on probabilities. Why? To provide time. So time is, again, the most critical variable. And what does the code say? The code says that anything above 3 minutes decreases considerably the chances of survival. How do we simulate? We simulate either two-dimensional, you take a picture of any architectural drawing, that's it, or you can even, bring in a 3D model, and then you can visualize the simulation in a much nicer way. So if the simulation is done, only based on 2D, well, you can see the drawings, the architectural drawings here, and they are, evenly spaced based on the height, and I just put some stairs to connect the drawings. And this particular building has 5 floors, and they have 2 exits on the south, 2 exits on the north, and then that's on the bottom floor. So if I start simulating, I can start seeing people, different colors per floor, then trying to leave, each and every floor. But the first and second floor, they're emptied rather quickly compared to the rest. You can see all the chaos here that it's going to be happening. So you can see people moving or trying to even here to move, on real time. Okay, as the clock moves, so is the simulation. They're timed extremely directly. Okay, now what if I have a 3-dimensional model? It's exactly the same building now being constructed in 3 dimensions, and if I play the animation again, I can see that those people are being alerted once the alarm goes off. But in the the setup cube on the 5th floor, which is the most critical, of course, because you're only providing one escape route. It's going to get crowded. It's going to get crowded rather rapidly. At 58 seconds, it's almost impossible to leave. And the problem's even compounded because people at rooms can't even leave. So you can see on the problem that I have here. And if I, speed up, the animation, well, what am I after? I am after times here. Okay, I can really evaluate, how long, the last person on the 5th floor is going to take for it to evacuate the building. So it's completely inefficient. I gotta let these, with this only escape route, and these floors have to breathe before, the top floors are even thinking about coming down. So I can evaluate, and I can evaluate the results on how fast the building took, or how long the building took for complete evacuation. I can see and evaluate that this took 13 minutes and 35 seconds. Completely inefficient. Design is extremely poor. But what if I told you that I can now evaluate the same kind of building but with alternatives? If the other project, the previous project, was a brand new project, I would immediately reject it, and I would tell them, you either widen the stairs or give me another set of stairs, but based on intelligence, not tables, intelligence, people moving. So I can certainly do that, and as soon as that happens, I can see that the cube is being used. But guess what? Another factor came in. And what is it? It is the fact that people now can move. The people can move, along along this new infrastructure, and I can see that the walk time. I can see the wait time and the walk time. I can certainly do that way, and this agent can even be tracked. Meaning that if I play the simulation, I can go along with its own path. So you can see that everything is dynamic. I'm going to pause it here, escape, and then move it and play the complete animation so I can evaluate. So if I hit play, even going to speed it up, and if I evaluate the time, it only took 3 minutes and 28 seconds. You just increased by 70% the chances of survival, doing it intelligent rather than table. Human lives are priceless.